You're probably familiar with a potentiometer. This is a knob sensor, so we can grab it and we can turn the knob. Usually it doesn't turn all the way, usually something like 270 degrees or 180 degrees. If you still have a device with a volume knob, that's probably a potentiometer. There are other sensors that can read rotation. We'll talk about those later. A potentiometer is nice because it is basically a variable resistor, but in most cases we don't use it as a variable resistor. We will use it as something like a variable voltage divider. In a schematic, you draw a potentiometer as a resistor with an arrow pointed at it. So this is a device with 3 legs, as you can see here on this blue version. This particular version from the top down has 3 legs in a triangle pattern. And we call them A, B, and W. And this one would have A, B, and W. So usually the W, the wiper, is in the middle. This particular model that you have in your lab kit is a 10K resistor from A to B, but you could buy these in all different values. And what's neat about it is that the resistance is always 10K from A to B, but the W pin is a resistor from A to W and from W to B that sums to 10K, but as you turn the knob, you can get 0 resistance from A to W and all the resistance from W to B. Or if you turn the knob to the middle, you can have 5K resistance from A to W and 5K from W to B. How do they do that on the inside? If we crack this thing open, there would be a horseshoe-shaped piece of probably polymer that has carbon embedded in it. So there's carbon all through here. And here's the wire that connects to A, and here's the wire that connects to B. And they put enough carbon in here that from A to B they get 10,000 ohms of resistance. Then there's a wire on the knob that scrapes up against this horseshoe shape. So this is connected to W. So as you turn the knob, this wire is touching different points of the carbon that's on the inside. So if we stretch this out to be a linear potentiometer, which is also a device you could buy, or if you just think of, I have a resistor and I sand it so that from one side to the other side I have the full resistance. So I sanded that resistor. Now there's this carbon in here. And if I put 5 volts on this side and ground on this side, that means there's a voltage gradient all the way across here. And if it's a linear amount of carbon in between, I get a linear voltage gradient. So right in the middle should be 2.5 volts. And a little bit over here would be like 3 volts and 4 volts. And over here would be less than 2.5 volts. And if I touched this wire, I'd get 0. And if I touched that wire, I get 5. So that's exactly how the potentiometer is working on the inside. So how do we use this? Typically we use it as a voltage divider. Meaning that we're trying to get some smaller voltage than one of the supplies. So for instance, I would take my potentiometer and I would put the bottom side to ground and the top side to 5 volts. And now as I turn the knob, I will get from 0 to 5 volts, depending on the angle. This particular version is a linear gradation, so it would change linearly with angle. You can also buy them with a logarithmic scale. That's typically used in for audio, like volume adjustment. So another thing that this is useful for is sometimes you need a specific voltage. You need 4.1 volts. And you could build an actual voltage divider with 2 real resistors to get that. But if you're in a pinch, you can plug in your potentiometer and monitor this output voltage as you turn the knob. And then you just stop turning when you get to 4.1 and then try not to touch it while you're using your circuit. The other way we can use the potentiometer is as a variable resistor. This is not as common, and typically what you do there is you just don't hook up one side of the potentiometer. So you just wouldn't hook up the back side. Now you've got a resistor R between the A pin and the W pin. So you could put this in, say, series with a real resistor. So we could have 5 volts to a real resistor to our variable resistor that's the potentiometer to ground. And we're just not going to hook up the 3rd pin. And maybe this is our output voltage. And now we can turn the potentiometer so that when we turn all the way to the bottom, we're essentially touching 0 and we're outputting 0 volts. And if we turn all the way to the top, maybe this is a 10K and this is a 10K, then we'd have 2.5. So now we've got a variable voltage from 0 to 2.5 volts. So this is not commonly used, the variable resistor. Typically we're using our potentiometer to get a voltage that's proportional to angle. So where would you use this other than just making voltages that are inconvenient to make with a regular voltage divider? Well, you could stick this into a robot arm, and you can move that robot arm around, and the voltage output would be directly proportional to the angle of the robot arm. And of course, there's lots of other things you could do with that. And there's also lots of different versions of this sensor that are more mechanically, receptible to be putting into a robot arm. This is one that basically you want to stick in a breadboard and turn by hand. You would probably integrate this one into a robot arm. So let's play around with it. I'm going to, first I just want to measure the voltage. Let's measure some resistances, and then we'll measure some voltages. So I'm going to stick, each leg needs to be in a different row. So I don't want to add it like this, because the A and the B would be in the same row. So I've got to make sure I turn it so that each leg is in a different row. And for now, let's just measure some resistances. So the top pin and the bottom pin, those are A and B. And so we should see 10K. If I try to measure the resistance, I'm going to go to the 20K setting on my multimeter. And note, something I'm doing here is I'm not going to try to push the sharp probes of the multimeter into the breadboard. It's just not sharp enough to touch on the inside. And it's a little hard to do this by hand, so I'm going to stick it into the breadboard to help. And so if I touch either side, see there we get about 10K. And now maybe I will read from A to W, and I'll set this. See, if I turn it, that's one end stop, and if I turn it all the way the other way, that's the other way. So this is like a 270-degree turn. So if I turn it somewhere to the middle, I should have 5K between A and W, so 4.8. This should be a little bit more to make the total of 10K between W and B. And I could turn it somewhere in the middle, and now this will be from W to B, it's a little bit more than 5, and this should be somewhere less. Okay, let's have it generate a voltage. So I'll have A be 5 volts, and B I will set to, let's say, negative 5 volts. So we know that all the way in one direction, when I read the voltage relative to ground, we should see positive 5 volts, and if I turn it all the way the other way, I should see negative 5 volts, and if I get it in the middle, I should see about 0. So let's test that out. I'll go to DC voltage on my multimeter, and I want to be on the 20 volt scale because I know I'll be seeing between plus and minus 5, and the 2 volt scale would miss most of that. And then I'm going to hold my black probe on ground and my red probe on W. So right now I'm getting 0.8 volts, and if I turn all the way to the top, I should get 5. If I turn all the way to the bottom, I get negative 5. And so if I turn to some random angle, I could now calibrate this to say 270 degrees is from plus 5 to minus 5, and I could calculate that angle based on this voltage. So that is the potentiometer.